So for today's video, we're going to be looking at absolute value statements. Today in class, we talked about absolute values when they equal a specific number. And we talked a lot about how it's the distance away from zero, okay? For this video, we're going to be just getting into the idea of using an absolute value with an inequality. Now there's a lot of tips and tricks that I'm going to tell you guys throughout the video. Remember, you can feel free to pause as we move along, okay? If we have the symbol with any sort of less than, or greater than, okay, we're going to be looking at x is the distance, or the distance from x to 0 is less than a units, okay? So it actually creates this little like dumbbell effect, so they are connected, just like an and statement, okay? So the way to remember that is it's less than, but act like you're a southern lady and say it as less than, okay? So the and statement, we have those little dumbbells. If you have greater, whether it's greater or greater than or equal to, we are looking at greater than a certain amount of units. So it's actually going off in two separate directions, okay? So it's going to be greater. So those or statements can go off in two separate ways. You can also think about it as the oars of a boat. So this one kind of looks like oars, less than, they are connected. Okay, so visually, these are the two tips and tricks that I want you guys to use. I'm going to use a silly southern voice, so hopefully it sticks in your head. Okay, when you're solving absolute value inequalities, we're going to follow these steps. We're going to isolate the entire expression. So you're trying to get inequality symbols equal to a number or the other side, okay? So whatever is in here, we're trying to get that entire expression alone. Then we're going to check to see that that expression makes sense. We can't have an absolute value less than a negative number. It could be greater than a negative number though, and we'll see some examples of that. We're going to write two inequalities and flip the sign and the symbol. The reason why is we have to make sure that we're showing that it could be the two different halves. So just like we saw up in this picture, there's two different dots. We're going to figure out, are they connected or are they going in opposite directions for the arrows. We're going to solve the two inequalities in graph. Let's start with something that already has the absolute value expression. So what's inside absolute value is already alone. There's nothing outside it to subtract or add. To start off, I have it written with the positive 5. I need to also break that into the two equations that are necessary. So the two equations that we could have 2x minus 1 is less than 5. And then I have to show that it has a twin. That twin, we are going to flip the sign and we're going to flip the symbol and flip the sign. So I'm going to have a greater than negative 5 now. Okay, I'm going to solve these out, add 1 to both sides of the first one, divide by 2, x is less than 3. The next one, you get 2x is greater than negative 4 when you add 1 to both sides, so x has to be greater than negative 2. Now I'm going to look back at the original problem because I want to figure out, is it an and or an or statement in this situation? So because the original symbol is less than, we're going to have less than, and we should have a dumbbell looking feature. Okay, these are open circle on both of them. So open circle at positive 3, open circle at negative 2. Because it's an and statement, we should be coloring in the inside. And we can double check to make sure that we are on the right track on that. The first inequality is x is less than 3. That should be moving towards the left. The x is greater than negative 2 moves to the right. And you shade in anything that they have in common because it's an and statement. Just to go above and beyond, to write this in interval notation, I would have parenthesis, negative 2, comma 3, parenthesis. For my next one, luckily, again, it is already, the expression is already by himself, so I can separate this into the two inequalities that we'll work with. We have 3x minus 4 is less than or equal to 8. The other one, we are going to have 3x minus 4 is greater than or equal to a negative 8. So flip the symbol, flip the sign. Okay, when we solve this, I would get, if you add 4 to both sides, 3x is less than or equal to 12, so x is less than or equal to 4. The next one, 3x is greater than or equal to negative 4, so x is greater than or equal to negative 4/3. It's okay to have things as fractions. MathXL can handle it, and I believe we can too. So we're going to look at the symbol from the very first inequality. It's a less than. So we should have in our graph, when we plot it, you should have that dumbbell looking graph. So I'm going to start with x is greater than or equal to 4. So I'm going to put a closed dot on 4. And x is greater than or equal to negative 4/3. So it's just a little bit over that negative 1. These are just going to be connected, creating that dumbbell feature. If I wrote this as an interval notation, I would put my smallest number. I need to include a bracket. Put my smallest number, negative 4/3, comma, positive 4, close bracket. Remember, we use the brackets because of the inequality symbols as well as the closed circles. Okay, we got one more of these guys. To start this off, we're going to separate those into the two inequalities. We have 2x plus 4 is greater than or equal to 6. Now I need to flip the symbol and flip the sign. So I'm going to have less than or equal to negative 6 for the second inequality. Okay, flip the symbol, flip the sign. When you solve this out, subtract 4 from both sides, divide both sides by 2, you get x is greater than or equal to 1. Subtract 4 from both sides of that next inequality, you get negative 10. Divide both sides by 2, x is less than or equal to a negative 5. Okay, we got to look back at that symbol. The symbol is a greater. So this is an or statement. We need to make sure that it looks like ors, and they're going to go in opposite directions for this one. For this problem, I have a closed circle on 1, and we want anything larger than 1 for this. We can also have anything less than or equal to negative 5, so I'm going to have a closed circle, arrow pointing off in the left. Remember from yesterday, we do have a special symbol to join this when we write it in interval notation. If I wrote it in interval notation, I would have negative infinity, comma, negative 5, closed bracket. Put the union symbol to join them. Bracket, the number 1 to infinity, parentheses. Just as a reminder, always next to infinities, you'll have a parenthesis because infinities never can be reached. Okay.